Okay, so we're supposed to have the line segment CD, which I went ahead and plotted on both of these graphs. And they want us to graph the image of CD after the glide reflection. So the first thing they want me to do, and they have this in translation form, they say take every coordinate and move it to the left 4, but do not move it up at all. So I'm going to take each point and I'm going to move it left 4, but I am not going to, let's see, I'll choose green. So I'm going to move it 4 to the left, but not up. That's what that means. 4 to the left, but not up. And then that'll be my new segment. Now I'm going to label this C image, D image. Okay. Next, after we do from CD to the image of CD, we are going to reflect it over the x-axis. And so, just a reminder, this is the x-axis, and we're going to flip now the green one over the x-axis, and I'll use purple. And remember, there are rules. Pretty much the way I like to do it is I don't like to memorize rules. You count. This one's 2 away, so it'd be 2 away here. This one is 1, 2, 3, 4 away from the line of symmetry. So I'm going to go 1, 2, 3, 4 away. Make my line. And now I'm going to label this as C image image, and then D image image, or some people call that prime. So I'll do that real fast. So we took CD, we moved it 4 to the left, and then we took that image and we reflected over the x-axis, and we got this line segment. So we just did what's called a composite transformation. Now I want you to try number 5 yourself. Okay, remember y equals x is the vertical or the diagonal. So if you're watching this at home, you could hit pause and see how you do. So we started with CD. First thing we did was we moved it up 2. We moved the red point up to green both times. And now we have C prime D prime, and we reflected it over the line y equals x. And so when you reflect over y equals x, all you do is you interchange the x and the y value. So the green point is 1, 4. So instead of plotting 1, 4, you plot 4, 1. And the other green point is 5, 6. So you plot 6, 5. And now you have your new image. So we just did what's called a composite transformation. So we are starting, and we're supposed to describe the composition of the transformations. We are starting here with ABC. We know we are starting there because we go from here to here, and then from there to there based off the prime notation. So first, I notice that to go from here to here, it looks like it's flipped over. That's called a reflection over the x-axis. So I will type in. The first thing we do is we do a reflection over the x-axis. I could also write that as you take your xy and that's an arrow. You keep the x the same and you negate the y. So that's the first thing you do. And both notations are the same thing. Now we're at this one, this triangle. And I notice that looking at it, it looks like it moved. And so what usually helps me is to plot a point on vertex A, and then the new A, and then count left to right. So I'm going to say, okay, I'm going 1, 2, 3, 4, 5, 6 to the right, and 1, 2, up. So I'm going to say I am going to, I could say move 6 to the right, 2 units up, or I could use more professional sounding language. Instead of move, I could use the word translate. And if I wanted to use mathematical notation, I would say you take your XY, and you take X, move it to the right 6, you take your Y, move it up 2. So that's what that notation means. I want you to try number 7. So you got to pay attention to which one's called the pre-image, the image, and then the second image. So describe the composition of the transformations. And if you're at home, you could hit pause and then look at the answer here in a second. So we started with ABC. We rotated 90 degrees to get this figure. That's called counterclockwise. We want one quadrant, so that's 90 degrees. The notation for that is you take your XY and you interchange the Y and the X, and you change your Y values to negative. And then we almost made a mistake. We thought this was a translation, but it's not a translation, because notice C, this would also be a C. So then we figured out it's actually a reflection over the x-axis, and we wrote the rule for that.